I think this might be a good place to define pre-training, mid-training, and post-training.
So pre-training is the classic training, one next token prediction at a time. You have a big corpus of data. And Nathan probably also has very interesting insights there because of Almo 3. It's a big portion of the paper focuses on the right data mix. So pre-training is essentially just, train across entropy loss training on next token prediction on a vast corpus of internet data, books, papers, and so forth. It has changed a little bit over the years in the sense people used to throw in everything they can. Now, it's not just raw data, it's also synthetic data where people let's say, rephrase certain things. So synthetic data doesn't necessarily mean purely AI made up data. It's also taking something from an article, Wikipedia article, and then rephrasing it as a Q&A question or summarizing it, rewording it, and making better data that way. Because I think of it also like with humans, if someone, let's say, reads the book compared to a messy, I don't know, no offense, but like Reddit post or something like that, I do think you learn, no offense, but I think...
There's going to be a post about this,
Yeah.
Well,
some Reddit data is very coveted and excellent for training. You just have to filter it.
Yeah.
I think that's the idea. I think it's like, if someone took that and rephrases that in a, let's say, more concise and structured way, I think it's higher quality data that gets the LLM maybe the same. You get the same LLM out of it at the end, but it gets there faster. It trains faster because let's say if the grammar and the punctuation is correct, it already learns the correct way versus getting information from a messy way and then learning later how to correct that and stuff like that. So I think that is how pre-training evolved and how still why scaling still works is that it's not about just the amount of data, it's also the tricks to make that data better for you in a sense. And then mid-training is, it used to be called pre-training. I think it's called mid-training because it was awkward to have pre-training and post-training, but nothing in the middle, right? It sounds a bit weird. You have pre-training and post-training, but what's the actual training? So the mid-training is usually similar to pre-training, but it's a bit more, I would say, specialized than pre-training. It's the same algorithm, but what you do is you focus, for example, on long context. Like as one example, you have long context documents. The reason you don't do that during just pure pre-training is because you don't have that many long context documents. So you have a specific phase. And one problem of LLMs is also still, it's a neural network. It has the problem of catastrophic forgetting. So you teach it something, it forgets other things. And you want to, it's not 100% forgetting, but it's like no free lunch. You can't. It's also the same with humans. If you ask me some math I learned 10 years ago, I don't know. I would have to look at it again.
Nathan was actually saying that he's consuming so much content that there's a catastrophic forgetting issue.
Yeah, I'm like trying to learn so much about AI. I was learning about pre-training parallelism. I'm like, I lost something and I don't know what it was.
I don't want to anthropomorphize LLMs, but it's, I think, the same kind of in that sense how humans learn. The quantity is not always better because, it's like being selective. And the mid-training is being selective in terms of quality content at the end. So the last thing the LM has seen is the quality stuff. And then post-training is all the fine-tuning, supervised fine-tuning, DPO, reinforcement learning with verifiable rewards, with human feedback and so forth. So the refinement stages. And it's also interesting, it's like the cost thing, right? It's like pre-training, you spend a lot of money on that right now. RL a bit less. RL, you don't really, I would say, teach it knowledge. It's more like unlocking the knowledge. It's more like a skill learning, like how to solve problems with the knowledge that it has from pre-training. There are actually 3 papers this year, or last year, 2025, on RL for pre-training. But I don't think anyone does that in production.
Toy examples for now.
Toy examples, right. But to generalize, RL post-training is more like the skill unlock, where pre-training is like soaking up the knowledge, essentially.
A few things that could be helpful for people. A lot of people think of synthetic data as being bad for training the models. You mentioned like the DeepSeek had almost OCR, which is optical character recognition paper. A lot of labs did. AI2 had one, had multiple. And the reason that each of these labs has these is because there's vast amounts of PDFs and other digital documents on the web that are in formats that aren't encoded with text easily. So you use these or DeepSeek OCR, and we called ours OCR, to extract what can be trillions of tokens of candidate data for pre-training. And pre-training data set size is on the order of trillions, is measured in trillions of tokens. Smaller models from researchers can be something like 5 to 10 trillion. Quen is documented going up to like 50 trillion, and there's rumors that these closed labs can go to like 100 trillion tokens. And just getting this potential data to put in, I think they have a very big funnel, and then the data you actually train the model on is a small percentage of this. Like this character recognition data would be described as synthetic data for pre-training in a lab. And then there's also the things like ChatGPT now gives wonderful answers, and you could train on those best answers, and that's synthetic data. It's very different than like early ChatGPT, lots of hallucinations data when people became grounded in synthetic data.
One interesting question is, if I recall correctly, Olmo 3 was trained with less data than specifically some other open weight models, maybe even Olmo 2, but you still got better performance. And that might be one of the examples how the data helped.
It's mostly down to data quality. I think if we had more compute, we would train for longer. I think we'd ultimately see that as just something we would want to do. And especially with big models, you need to have more compute because we talk about having more parameters and we talk about knowledge. And essentially there's a ratio where big models can absorb more from data, and you get more benefit out of this. It's like one of these, any logarithmic graph in your mind is like a small model will level off sooner if you're measuring trillions of tokens, and bigger models need more. But mostly is we aren't training that big of models right now at AI2, and getting the highest quality data we can is the natural starting point.
Is there something to be said about the topic of data quality? Is there some low-hanging fruit there still where the quality could be improved?
It's like turning the crank. So I think historically in the open, there's been like a canonical best pre-training data set that has moved around between who has the most recent one or the best recent effort. Like AI2's Dolmo was very early with the first Olmo, and Hugging Face had FineWeb. And there's a DCLM project, which has been kind of like it stands for Data Comp Language Model. There's been data comp for other machine learning projects, and they have had a very strong data set. And a lot of it is the internet is becoming fairly closed off. So we have Common Crawl, which I think is hundreds of trillions of tokens, and you filter it. And it looks like being a lot of scientific work where you're training classifiers and making decisions based on how do you prune down this data set into the highest quality stuff and the stuff that suits your tasks. So previously language models were tested a lot more on like knowledge and just kind of conversational things, but now they're expected to do math and code. So to train a reasoning model, you need to remix your whole data set. And there's a lot of actually wonderful scientific methods here where you can like take your gigantic data set, you sample a lot of really tiny things from different sources. So you say you have GitHub, Stack Exchange, Reddit, Wikipedia, you can sample small things from them, and you train small models on each of these mixes and measure their performance on your evaluations. And you can just do like basic linear regression, and it's like, here's your optimal data set. But if your evaluations change, your data set changes a lot. So a lot of Olmo 3 was new sources for reasoning to be better at math and code. And then you do this mixing procedure and it gives you the answer. And I think that's a lot of that's happened at labs this year. It's like there's new hot things, whether it's like coding environments or web navigation, and you just need to bring in new data. You need to change your whole pre-training so your post-training can work better and stuff like this. And that's like the constant re-evolution and the redetermining of what they care about for their models.
Are there fun anecdotes of what sources of data are particularly high quality that we wouldn't expect? You mentioned Reddit sometimes can be a source.
Reddit was very useful. I think that like PDFs is definitely one.
Especially archive.
Yeah, so like AI2 has run Semantic Scholar for a long time, which is what you can say is a competitor to Google Scholar with a lot more features. And to do this, AI2 has found and scraped a lot of PDFs for openly accessible papers that might not be like behind the closed paid garden of a certain publisher. So like truly open scientific PDFs. And if you sit on all of these and you process it, and you can get value out of it. And I think that like a lot of that style of work has been done by the frontier labs much earlier. And it's just like, you need to have a pretty skilled researcher that understands how things change models, and they bring it in and they clean it. And it's a lot of labor that, like, I think of a lot of frontier labs when they scale researchers, a lot more goes into data. You have people like, if you join a frontier lab and you want to have impact, the best way to do it is just find new data that's better. And then like the fancy glamorous algorithmic things like figuring out how to make O1 is like the sexiest thought of a scientist of like, oh, I figured out to scale RL. And there's a group that did that, but I think most of the contributions is like,
on the data
I'm going to
side.
make the data better, or I'm going to make the infrastructure better so that everybody in my team can run experiments 5% faster.
At the same time, I think it's also one of the closest guarded secrets what your training data is for legal reasons. And so there's also, I think, a lot of work that goes into hiding what your training data was, essentially. It's like trying the model to not give away the sources because of legal reasons.
The other thing, to be complete, is that some people are trying to train on only licensed data, where Common Crawl is a scrape of like the whole internet. So if I host multiple websites, I'm happy to have them train language models, but I'm not explicitly licensing what governs it. And therefore, the Common Crawl is largely unlicensed, which means that your consent really hasn't been provided for how to use the data. There's another idea where you can train language models only on data that has been licensed explicitly, so that the kind of governing contract is provided. And I'm not sure if Apprentice is the copyright thing or the license thing. I know that the reason that they did it was for an EU compliance thing where they wanted to make sure that their model fit one of those checks.
And so on that note, also, for example, there's also the distinction between the licensing. So some people, like you said, they just purchase the license. Let's say they buy a book online, let's say an Amazon Kindle book, or let's say a mining book or something, and then use that in the training data. And that is like the gray zone because you paid for the content and you might want to train it. But then there are also restrictions where even that shouldn't be allowed. And so that is like where it gets a bit fuzzy. And yeah, I think that is right now still a hot topic. And also big companies like OpenAI, they approached private companies for their proprietary data, and private companies, they become more and more, let's say, protective of their data because they know, okay, this is going to be my moat in a few years. And I do think that's like the interesting question where if LLMs become more commoditized, and I think a lot of people learn about LLMs, so there will be a lot more people able to train LLMs. Of course, there are infrastructure challenges, but if you think of big industries like pharmaceutical industries, law, finance industries, I do think they at some point will hire people from other frontier labs to build their in-house models on their proprietary data, which will be then again another unlock with pre-training that is currently not there, because even if you wanted to, you can't get that data. You can't get access to clinical trials most of the time and these types of things. So I do think scaling in that sense might be still pretty much alive if you also look in domain-specific applications, because we are still right now in this year just looking at general-purpose LLMs on ChatGPT, Anthropic, and so forth. They are just general-purpose. They're not even, I think, scratching the surface of what an LLM can do if it is really specifically trained and designed for a specific task.
I think on the data thing, this is one of the things where like this happened in 2025 and we totally forget it, is Anthropic lost in court and was owed $1.5 billion to authors. Anthropic, I think, bought thousands of books and scanned them and was cleared legally for that because they bought the books. And that is kind of going through the system. And then the other side, they also torrented some books. And I think this torrenting was the path where the court said that they were then culpable to pay this billions of dollars to authors, which is just like such a mind-boggling lawsuit that kind of just came and went. Like that is so much money from the VC ecosystem.
These are court cases that will define the future of human civilization, because it's clearly that data drives a lot of this. And there's this very complicated human tension of, I mean, you can empathize. You're both authors.
Yeah.
There's some degree to which, I mean, you put your heart and soul and your sweat and tears into the writing that you do. It feels a little bit like theft for somebody to train your data without giving you credit.
And there are, like Nathan said, also two layers to it. Someone might buy the book and then train on it, which is could be argued fair or not fair, but then there are literally straight up companies who use pirated books where it's not even compensating the author. That is, I think, where people got a bit angry about it specifically.
Yeah, but there has to be some kind of compensation scheme. This is like moving towards something like Spotify streaming did originally for music. You know, what does that compensation look like? You have to define those kinds of models. You have to think through all of that.